Good morning. It is July 21st, 2014. This is Jason Horak reporting on the ongoing adventures of the Dodge Daytona electric vehicle. Specifically, what we're looking at today is charge issues. I've been having a problem lately where the charger is not terminating when it's supposed to. This is despite the charger being calibrated to a particular voltage, in my case 210 volts, where I've caught the charger going past that on a number of occasions. And I think what's going on, perhaps, is that the voltage sensor inside the charger may be damaged, or it may be susceptible to temperature changes, because sometimes the charger will stop exactly on the voltage that I've requested, and it's all fine. Other times, it'll just keep on putting in 40 amps into the pack, long past that voltage, and keeps on going, potentially damaging the batteries. So that's no good. So we need to fix that, figure out what's going on. This problem is new. I've had this charger since 2010, and it's been sent back to Manzanita 3 times for repairs after I blew it up for various reasons. This last time when it came back from the repair is when this new problem has occurred. So it just may be an issue with the maybe it was damaged in shipping, or maybe when they were repairing it last time something got bumped, I'm not really sure. Or maybe last time when I killed the charger, it damaged the voltage sensor, and they didn't catch it when they were doing the repair. I'm not really sure. But anyway, it works sometimes. It'll stop at the voltage that I have it set to, which is 210 volts is how I have it calibrated. And then sometimes it'll go to 211, 212, 213, 214, 215, and climbing. Luckily, I've been around to catch it most of the time, and have been able to turn the amp knob down on the charger or unplug it to terminate the charge. So let me go ahead and show you the project that I'm working on to solve that problem, and also to add in kind of a protection mechanism to prevent that from happening in the future. Be right back. As some of my longtime viewers may remember, from 2013 at the last electric vehicle conversion convention out in Cape Girardeau, Missouri, I had a bit of an incident. Basically what had happened was that my charger, which is set with the programmable buttons on the front of it for a certain voltage, had gotten bumped during shipping, and instead of stopping at the 210 volts that it was supposed to stop at, it had gotten reprogrammed, again with an accidental elbow or whatever, to 310 volts. Now, if it had been allowed to charge the pack all the way to 310, most likely it would have caused a fire, and it was kind of a scary event. I had happened to be standing next to the car when the DC-to-DC converter blew up, after hitting about 263 volts, I believe, and it was a scary event. Anyway, while I was there, a fellow EVer and convention attendee named Dale Friedhoff, who happened to have his, I believe his red pickup truck parked pretty close to my Daytona at the time, recommended that I set up some kind of fail-safe so that this doesn't happen again in the future. In fact, it bothered him so much that he had gone out, and I'm not sure how well the camera will make this up, but he drew this schematic of a circuit diagram in order to create essentially a programmable disconnect for the charger using 2 Tyco kilovac contactors, a JLD 404 meter with its built-in relay to be able to toggle some circuits off to turn off these, actually these are also relays, to turn off the Tyco kilovac contactors and thus cut power to the charger. So this is like the wall and to the charger. He's got some other stuff going on up in here, which tie into a J1772 plug and stuff like that, which I don't use in my build. Anyway, it was very, very thoughtful of him to put this together. I didn't end up using his schematic exactly because he had described it that day when the overcharging incident happened, and I kind of had an idea in my head from just his description of it, and didn't really need the diagram, but I do appreciate him taking the time to create it anyway. So anyway, Dale Friedhoff, thank you very much. So this whole project, or section of the project, is devoted to you, so thank you. So anyway, this is the project that I'm working on right now, which is the disconnect for the charger in the event of a overvoltage situation. So I wired up this little test setup to kind of show you what it is that I'm trying to accomplish, and give you some examples of how this works. So what I've got here is a 12-volt battery, which is going to simulate our basically our wall outlet in this particular experiment. So we've got positive and negative wired to that, and the positive is going through this contactor and then through this contactor to this light. The negative is wired straight through. So basically what contactors do, for those of you who may not know, is all it has in it is a magnet that when it gets a positive and negative signal on its two leads coming in here, it moves a little electromagnet, or it moves a little piece of metal like a bar up on the other side of these contacts, and that thus makes contact between them because of the magnet bouncing up there. So basically what it does is the same thing as putting a wrench on here, and as you can see, the light lights up when both of these are crossed. So anyway, that's all the contactors do. When they turn on, the light will come on. Yay! So that's what all this is about, is just to demonstrate that the contactors are actually engaging and disengaging at the appropriate time. They'll light up the light, or not, as the case may be. So the way we get power to them is with this little device, which is a JLD 5740, and it is a voltage meter. So this just measures voltage. It doesn't do the amp hours like the JLD 404, but you can program it the same way as the JLD 404, and it has basically two small relays inside of it that activate based on how you program it, and we'll get into that in a moment, and specifically how it's wired. I will zoom in the camera so we can see that. But providing power to this whole ensemble on this side of the equation is this little laptop power supply. We had a whole lot of old laptop, this is fairly old. This particular laptop power supply puts out 19.5 volts and, let's see, 4.62 amps. So about 90 watts is what this thing is rated for. Much more power than we actually need for this application, but it's what I had laying around, and I think it'll work out well as to get the job done. So basically we're just going to plug that in and go from there. So what I'll do is, and then these are my sense wires. So this is what I'm going to hook up to the main battery pack to sense the voltage for positive and negative of the entire pack, which will then make some decisions based on how this is programmed to activate these two contactors. Now, why would you go through all this effort? What's the point? Well, the point is that each one of these contactors, they won't be wired together like they are here. They will be wired individually to the two separate hot legs of this 220 outlet. So basically, the wire that goes from here will go to one side of this, and then the other side of this will go to the wall. Same on this side. This one will go to here, and then from there to the wall. So in so doing, I can turn on and off the hot leads from here, both of them, by activating both of these contactors. In turning them on and off, we'll effectively plug and unplug the charger from this outlet. So that is kind of the goal, that is the objective to this whole experiment, is to eventually get to that point. But for the purposes of testing, and just to show you how it works, we're going to be using a low voltage programming setup with this little 12 volt battery as one of the power sources, and the 19.5 volt power source coming from here as another level to kind of demonstrate how this thing is programmed. But okay, I'm going to go ahead and reposition the camera, give you a closer look at how this particular meter is wired. The wiring is very straightforward, but again, I want to kind of go over it for sake of completeness. Be right back. Okay, so the JLD 5740, which is what it says on top there, digital voltmeter, and I believe it's made by the same company as the JLD 404. It says on top QBKJ, whatever that is. But anyway, the wiring on this is actually pretty straightforward. So we've got pins 1 and 2, these two up here, and again, I'm not sure if the camera is making it out, but these are all numbered. So 1 and 2 coming from this side are the positive and the negative input voltage. So right now I've got that hooked up to the 19.5 volts, and I've got these two little jumper leads that are just here and here that go from pin 1 to pin 15 and pin 2 to pin 12. So what those are is these are the center points for the relays, and what they are is when they're both on, they go this direction. So it would connect pins 12 and 13 and pins 15 and 16, like that, is when they're on. And when they're off, they go this way. So they connect pins 11 and 12 and 14 and 15. So that's the way that the relay works inside here. There's two relays, and I've got them wired up to the positive and the negative so that I can actually switch my two contactors that are connected here by either turning off the positive or turning off the negative. It gives me a little more flexibility and allows me to make better use of the capabilities of this little meter. So pins 5 and 8 turn out to be the positive and the negative of these sense wires. So, and that is respectively. So 5 is the positive, 8 is the negative. And so these are eventually going to be hooked to the to high voltage wires that'll go to the pack. They'll just be small gauge high voltage wires. They're just, again, sense wires. So they're just sensing the voltage. They're not carrying any current to speak of. So anyway, that is the wiring for this little meter. So what we're going to do is we're going to go ahead and reposition the camera again, and this time I will show you some of the programming of how this thing is set up. Be right back. Okay, now I know the camera isn't focusing very well on the device, but it should be able to make it out clear enough for us to be able to see what's going on. So what we've got is 0.00 volts. That is showing us that we are measuring with our two sense wires nothing currently. And we've got the top light and the bottom light are both illuminated. What those indicate is the top light is for the first relay and the bottom light is for the second relay, and they light up whenever they're on or in the on position. So again, this is relay number 1, which is hooked to the positive, and number 2, which is hooked to the negative. So number 1, J1 there, is in the on position. It's that way. So it's connecting these 2 points together, and J2 is in the on position, which is connecting these 2 points, which is the wire coming in and then nothing. So even though they're both in the on position, that doesn't mean that the contactors are on. Only when this one's in the on position and this one's in the off position will both contactors engage. And that's important because that's how I've got it programmed to do a variety of really cool things. So let me go ahead and show you how this thing is programmed and why it works the way it does. And then we'll actually show you how it behaves. So what it's got is these 4 little buttons. The one on the left is like the menu button. And the next one over is a kind of a right arrow kind of button. Then down and then up. And so what we're going to do is go over here and put in number 1 for the function. So I just used the menu to get to here and then the right arrow until I got to the last column and then made it 1. And then you press menu again and it gets you into the programming menu for the relays. So there are 4 values, AH1, AL1, AH2, and AL2, and then back to end when you're finished. So it gets a little bit complicated and it's hard to explain, but essentially by setting the value of the high value of this, again this is a voltage reading, to something that is lower than the low value, you get some very interesting results. So in this case for AH1, so again this is the high value for relay number 1, is I've got it currently set to 12 volts. Pretty straightforward. AL1, so the low value, is set to 19 volts. Now, I know this is really counterintuitive, and it took me a long time to wrap my head around it. And I'm probably still not going to explain it right, but I'm going to try. Basically, what it does with those 2 settings is that when the voltage is at 0 through 19 or 18.99 volts, the contactor will be in the on position, like it is here. We've got 0 volts, it's on. If it gets over 19, it will turn that contactor off, and it will stay off until the meter drops down again to the high value, which is 12 in this case. So anywhere between 0 and 19, it's on. Once it exceeds 19, it turns off, and then it will stay off until the meter reads, or until it comes back down to at least 12. Now, what that does for us is it allows us to set it so that on the charger, that in this particular case, we would say, okay, so L1 would be the high value of where I want the charger to stop. You know, in this particular test case, I'm saying 19 volts, but my actual charger would be like 210. Then for the high 1 value, I would set it to something like 200 volts. And what that means is that the pack would charge to, in this case, 19 volts. It would shut off the contactor by shutting off this relay, and then it would stay off until the charge comes down and the battery settle to 200 volts, in which case it would engage the contactor again. It would engage the relay, which would engage the contactors, which would turn the charger back on, bringing the pack back up to a max of 210, where it would shut off, and the cycle would continue. That cycle wouldn't be very quick. It wouldn't be like an on-off, on-off, on-off thing, because the batteries take a while to settle. Sometimes up to 24 hours, depending on until they're completely settled. But anyway, so what's kind of interesting about that is that you could leave the charger plugged in pretty much continuously, and even with parasitic loads on your pack, it would cause the charger to kick on every time the pack dropped below whatever the low set value is for where the batteries settle. So if they drain down to 199, charger would kick back on. it would charge up to 210, shut off, and settle down to 200, and so forth. So anyway, so that's kind of the weird thing about this whole relay, is that it's backwards. So the high is actually the settle point, and the low is actually the cutoff point for the purposes of how we're using it. So anyway, so that's that. Now the 2, again, back to the black connector, I've got the high set to 5 volts and the low set to 10. So once again, I've got them inverted. Let's see, is that a true statement? Let me double check. So the high is 12, low is 19. Yes, high is 5, low is 10. Okay, so for the 2, the reason why I have it between 5 and 10. So that means that this second contactor will be on anytime it's below 5 volts, and anytime it's up to 10 volts. As soon as it hits 10 volts, it's going to turn the contactor off. So again, just like the top one turned off at 19, the bottom one's going to turn off at 10. And what that does for us is that because I have this wired backwards, so to speak, so that the contactor is connected on the other side, that means that it's in the on position, it's this way, nothing's happening. And when it goes to off, it actually completes the circuit. So what we can do here is ensure that the charger never turns on unless there is a voltage on the meter. And so this bottom relay will always be in the on position when we're below 10 volts in this particular configuration. And technically it would allow for that whole thermostat thing of between 5 and 10, that if it hit 5 volts and then charged up to 10, I think it would stay off. But anyway, it doesn't really matter, because what this does for me is something that I've never had before in the car, is a protection circuit, so that if my big red button is turned off in the front of the car, that disconnects the entire battery pack, breaks the circuit of the battery pack, that drops the voltage to 0. And if you plug in a Manzanita charger and crank it up to full amps, when the pack is disconnected like that, you can actually damage the charger. And it says very emphatically in the documentation never to do that. For that very reason, because you don't want to blow up your charger, so never plug it in when there's no load on it. So with this kind of configuration, it means that the battery, or the charger, will never be engaged, these contactors will never be engaged when there's no voltage on it. Okay, so now we're going to go ahead and show you how this all works. As you can see right now, we are measuring 0.00 volts, and that both of the relays are in the on position. So we're going to go ahead and put this on a 12 volt power source, in this case the battery. So as you can see, we're measuring the voltage at 12.56, and the bottom relay is now off. And so again, that is the negative side here. So it was on, which is to the left, and it's off to the right. And so that causes it to make the circuit. The top relay remained on, again to the left, and that is why we currently have a circuit that goes all the way through, engages both contactors, and thus allows the light to illuminate. So that's kind of in the happy range. Temporarily, as you can see, I've wired up this little 9 volt connector, just so that we can easily get the clips on here. And I'm going to show you what it does when we remove it back to 0, again, both are on, and thus the circuit is not complete. And then we are going to put it onto here, and I believe that the positive is actually this side, and the negative is this side here. So that will stay. So as you can see, we're measuring 19.98 volts now, and both relays are off. So we are over the 5 or 10 volt range, thus the bottom one is in the off position, and the top one we have now exceeded that 19 volt specification or setting, which turns that one off. Now if I had a way to slowly reduce the current, or sorry, slowly reduce the voltage rather, to below 19, that would stay off all the way down to 12 volts. And at which point it would turn back on again, that top relay number 1, or the red positive relay. So, but the only other thing I can show you is kind of an interesting couple things. One is that we'll go ahead and put our valid voltage range back on. So again, this would be in the happy range for the charger, which is more than 0 volts, but less than the maximum that we want it to stop at. Now, if this device should fail, or this power supply should fail, we end up with losing power. And because of the way that it's wired, it requires that one of these relays be left on and one be off for the contactors to stay engaged. The contactors are also engaged by the power that is from this unit. So if this thing fails, it shuts off, it won't charge. And that's the failure mode that I want it to be, that if either one of these relatively inexpensive parts fails, it just simply will not charge, as opposed to charging without any kind of protection. So what's also interesting to note is that with this hooked up to here, so it's in the 12 volt happy range at this point, when we first plug it in, you'll note that both relays are off. And so this would simulate the pack being between 200 and 210 volts, would fall within the range of that low and high for the first relay, which means that it's in the off position when it first comes on in that range. And so it's kind of on the downhill slope of the measurement, so that when this would get to actually 11.99 volts, it would re-engage that first contactor, or first relay rather, turn on the contactors, and thus turn on the charger. So it's just kind of an interesting thing that when you first plug it in, if the pack is already charged and is already over that minimum voltage that you want it to settle at, then it won't turn on the charger, and it just no harm, no foul, and then it should turn on automatically. Again, I have no way of really testing that because I can't vary the voltage dynamically on my little test setup here, but in theory it should work that way, and we'll be testing it out in the car, without hooking up the charger, just hooking up the 12 volt power source, or 19.5 in this case, and hooking this up so you can see the meter and see the relay, or hear the relays click on and off. I mean, I might even set it up in the car with this little light and the little 12 volt battery, exactly as set up here, but with the sense wires on the main battery pack, and reconfiguring this guy to the higher voltage, just to go through the whole process with the actual pack voltage, and then I can kind of observe how, as the pack settles, when does it turn on the magic little light and all that kind of stuff, without directly affecting the charger until I'm sure that it's going to work.
So anyway, that's probably the next step. As you can get to kind of see in the back of the frame here, I do have a box. So this is a little $22 box from Lowe's that I'm hoping will be large enough to put all of this stuff in. It has kind of a watertight rubber seal around the edge, which isn't going to matter too much because I'm going to cut some holes in it. And one hole is going to be for the meter, kind of at the top. And then we're also going to have the outlet for the charger mounted in this box as well. So that's kind of the plan there. Inside of this box, what I'm going to do is simply cut this extension cord so I have a outlet that I can plug this guy into, and then this will be powered from the same incoming lead that powers the charger. So it's by taking one of the legs here, because again we've got the ground, the neutral, and the two hots. Well, for a 110 outlet, it's just ground, neutral, and hot. I forget which one's which on this one. I'll have to look that up. But we basically only use 3 of the connectors. So the point is, I will hook this up, bypassing, the relays, and then this will be hooked up through the relays, and we should have power for this entire setup supplied by the wall plug when we're charging. So none of this will even turn on at all unless you've actually got the the wall plug in. So none of this runs off of the battery power from the car. Again, that's both a safety feature and kind of a removing a parasitic load from the pack kind of feature. So I think it'll be kind of cool. Hopefully it'll work the way I intend to, and that's the plan. We'll go ahead and get that hooked up in the car, and we'll go from there. Alrighty then. So as you can see, I have moved my test setup here to the car, and I'm using my plexiglass sheet that protects the front battery box as a convenient shelf to do this particular test on. All the wiring is the same as it was in the house. We have our battery simulating the power coming in from the wall, going through the 2 contactors, and then the light simulating the charger with this whole setup. Configuration wise, I had to change the sense wires to now be on the main battery pack, pack positive and pack negative, and I used a different pin on the meter. So previously I was using pin 5 for the voltage sense, and that was the 0 to 100 volt range, and now I'm using pin 4, which is the 0 to 500 volt range. And so that just had to change in order to be an appropriate measurement for the around 200 volts that the pack generally is at. And so I'm going to go ahead and plug this in and show you how the configuration on the meter was done, so that you know what's going on. Now I want to specifically mention that I did not figure out how to program these things on my own. I cheated off the smart kid, Jack Rickard at EVTV, went through and made a very good documentation for this meter and the JLD404 on how to configure them, and he kind of did a translation from the original Chinese not very good documentation to very clear steps on how to do it. So we went to number 89 on the configuration here, which is the P-SN. P for some reason means voltage, so this is the voltage sense, and it's configured at 0 right now. You can look at his documentation. It shows what each of these numbers mean, but 0 is for pin number 4, and 1 would be pin number 5, 2 is this pin number 6, and I think 3 is pin number 7, and there's some other configurations with resistors and stuff, I believe, to configure it for other ranges, but anyway, so that's what all it is for that. And so the other thing that I had to do is that this meter isn't calibrated precisely the same way as the JLD 404. And so what I had to do was go in here into the 36 menu, which is the general configuration for it. And PUL is the voltage low, basically the 0 point of the meter, which I have it set to 0. The high, this is the one that I had to play with. Originally this was set to 9999. And what that meant was that when it was sensing my battery pack, it was really high compared to my JLD 404. My JLD 404 was showing 199, and this was showing something like 250 or something. It was very inaccurate. And so I had to tweak this setting up and down until I found the range where the meter now shows what my JLD 404 shows at my 199 point whatever. So anyway, 564 is what I ended up coming up with there for this particular configuration. Also, the decimal place, when I was in the kitchen, I had this set to 2 because I was dealing with 12 volts and 12 point something and 19 point something. Out here in the car, we have to set it to 1 decimal place because we're dealing with 3 bigger numbers basically. So yeah, 199.7 is what we're currently showing. So the other part of the configuration that I changed was the number 1 configuration menu, and that was this one that I showed you before with the AH1 is set to 200 volts. That's the settle point for the battery pack, and AL1 is set to 210. That's the maximum cutoff where it will shut off this particular relay, this first relay, at 210 volts, and then it'll stay off, theoretically, until the pack hits 200 volts when it settles. I also changed the AH2 to 50 amps and the AL2 to 100 amps, 100 volts and 50 volts respectively. And so what that is that's just so that when the battery pack gets below the 50 volts, it will engage this bottom relay, which also terminates the power to these contactors. So that's kind of the whole setup there. Let me go ahead and show you how it works. So as you can see, we're plugged in right now. The light is on. We're below the 210, and in fact below the 200 volt range at this point. So it's on, ready to charge, basically. Just to give you an example of why this is handy. So if I shut off my big red kill switch, the voltage drops, and when it hit below 50 volts, it disconnected the contactors. So that would kind of simulate, again, if you hit that switch, your charger is not going to come on accidentally and damage the charger. So it takes a little bit for it to bleed off the surface charge on the contacts and so forth, but eventually it should get down here to 0 volts. So that's what that AH2 and AL2 settings were all about. Basically anywhere below 50 volts, it's going to shut that contactor or turn that contactor on, and the high value doesn't really matter for that one because it just stays. Actually it does matter, because when it's over 100 volts, it's going to shut that relay off, and that's what it needs to be off in order to charge the pack. So the top one, again, is on because we're below the 200, or below the 210 rather, and there we go. So okay, so what I'm going to do now is I'm going to turn on the charger, and we're going to get some I'm going to let it charge up to 210 volts, and so you can see what happens with the light, and then we're going to let it settle to get it back to the 200 volts. Now it does take quite a long time to settle, so I may have to pause the camera and help it along a little bit by running the motor to bring it down to the 200 volts in a relatively rapid fashion, but you'll kind of get the idea of how it works. So, alright, so let's see, we're going to plug in the charger. And now I'm going to crank the the amp knob up on the charger. And then you can hear my wonderful DC to DC converter whistling away. And you can see the voltage climbing rather rapidly. We are at the pack is fully charged at this point, so we're doing the normal charge cycle, and we're going to push these cells all the way up to 210, which works out roughly to 3.5 volts per cell. And so this may take a minute, and I could pause the film, but I think we're okay. It's going up fast enough that I'm not going to bore everyone completely to tears on this phase of the thing. So again, this is representative of the first relay is in the on position, and it will shut off, in theory, at 210 volts, and will stay off until the pack reaches the settle point of 200 volts. Because of the way this meter is configured, it is in the on position while we're ascending from 200 to 210. And it will be in the off position while we're descending from 210 back to 200. So that's kind of the whole magic of this thermostat effect of this particular meter. And I apologize again for the loud, obnoxious whining noise that's coming from the DC to DC converter, but really can't be helped at this point because I need my 12 volt power in the car. So anyway, we're approaching the 210 again very rapidly. You can hear the charger spooling up as it is getting really warm, and there goes 210, and you saw the light turned off. So now I'm going to go manually turn off the charger because I don't want it to keep on running. So just turn the voltage knob down, and you can see that the turn the amp knob down, and now you can see that the voltage is dropping as the pack starts to settle post-charge. So again, I'm probably going to have to help this along a little bit just to make it go a little faster on camera, because this will take perhaps an hour to fully get to the 200 volt range, just because it takes a while for the chemicals and the batteries to settle, and after being charged. And even though we only ran the charger for a few seconds here, it still will take a while for it to get back to nothing. So I'm going to go ahead and turn on the controller, and I'm going to turn on the headlights and the heater and the fan blower and probably the power steering pump, and just get everything going. And I'm going to idle the motor with the transmission engaged but in neutral for about for as long as it takes to get that voltage down close to the 200 mark that'll cause it to settle at. And again, this will happen naturally over time, but it'll take a lot longer than I'm willing to sit here and run the camera, as it were. So, be right back. Alright, so I ran the motor for a little bit, again with the clutch not engaged, therefore it was kind of fighting against the mechanical resistance of the transmission even in neutral. I had the headlights on and the heater blaring and doing as much as I could to drain the energy. So I'm speeding along the process that would have normally taken, perhaps up to 24 hours for it to settle to the 200 volts after being charged. So I've got it at the point where it's at 200.3 volts, and I'm going to go ahead and run the motor just while we're filming, so you can see what happens when the voltage hits the 200 mark. Here we go. So as you saw, it dipped below 200 there just ever so briefly, or at 200, and that turned back on the light, and so we're now back in that ascending range. So before we were descending down from the 210 to 200, and now we're going back up again, essentially. So this would turn back on the charger, at which point the charger would keep on cranking all the way until we got to 210, and it would shut off and the cycle would continue. So that's pretty cool. So that's kind of the whole thing there. And the last thing that I want to show you is what it does when the voltage is already high enough. So what we're going to do there is I'm going to put it back on the charger just a little bit to get it back up into the over 200 range comfortably. Okay, so that ought to do it, I hope. And then what I'm going to do is unplug this. So it's like we've unplugged the charger from the wall, which is, again, when we unplug the charger, it's going to unplug this and disconnect this whole thing. Now when we plug it back in, with the pack being charged already, and again, we're kind of on that, it thinks that we're in the downhill, the drain phase, which we are. You'll see that the light is off. And so basically when the pack is already charged and you plug in the charger, nothing will happen. And again, the no harm, no foul, it'll just sit there and be like, okay, whatever, waiting for the pack to drop down. Once the pack does drop down, again, we will simulate this by running the motor. And so as you can see, once it hit the 200 volts, again, light came back on, starts charging, and we're off and running. So I think this is pretty much the most perfect setup that I can come up with for a charger controller. So my plan is to get all this assembly put into that little box that I showed you earlier, and we'll go from there. Alrighty then. So before we go ahead and proceed with the installation of the new Charger Buddy device in the car, I kind of wanted to go over how I have the charger connected and have for many years. Just kind of show you the wiring, and that way we'll kind of have a baseline for where we started and then where we end up. So essentially what we have is two very large gauge wires. I'm not sure if the camera's making them out or not, but they're pretty beefy wires, and these go up to the front battery, the main pack, positive and negative, up at the bus bars in the front of the car. It's all in this special conduit that is super strong, and prevents water from getting in there, as well as any kind of abrasion. You'd really have to do quite a lot to get through the this plastic covered conduit stuff. And anyway, so on the end we have the Anderson 120 amp power pole connectors, which can be configured kind of any way you want. I have them with the positive on the left, or positive on the right, and negative on the left. So that's just kind of how we set it up with from Brian Kokoran, I believe is how you pronounce his name, from EVCCON 2013, who sold me that new charger and wired this up in the car for me. So what I ended up doing after I repaired my PFC 40M, I swapped out the connector and put this the 120 amp power pole Anderson deals on it to make sure that I could just plug it in without having to have any kind of adapter with the car. And then I can swap out chargers. I can put in the PFC 50, which has those on it, and just swap it just by plugging it in. Anyway, on the AC side of things, the charger came with a standard NEMA 14-50 plug, and thus I created a NEMA 14-50 outlet. This is just a regular indoor type of thing that you'd find for plugging in your dryer or electric stove. And I just wired it up with this heavy, 4-wire, 50 amp rated cable. That's the same kind of stuff, again, that you would run from your electrical box to one of these types of plugs on the wall. So it's really hardy stuff. If you remember from my old video, that goes all the way to the power outlet plug on the side of the car, out here, and is in PEX tubing for inside the wheel well, and then it comes down underneath and comes into this mid battery box over there on the side. So that's what this whole cable is, my power input from the wall essentially to the outlet on the side of my car and into this outlet inside. So what we're going to be doing today is replacing this receptacle with our little new device, and then I'm going to be running the sense wires into this set of cables. What I'm going to do is pull out there's kind of like little metal poles in there that are crimped onto the big wire. I'm going to pull these out of the plastic enclosures and see if I can slip in the sense wires into the same metal to crimp them into the same connection as the actual wires that run to the pack positive and pack negative on the main battery connections up front, the bus bar. So that'll be my sense wires for the high voltage, positive and negative. That'll be running into my little box, and then I'll have this wire here, just this big old honking cable from the AC, also running into the box. Now what I'm planning on doing is I'm going to run it in this big conduit stuff, again, just to kind of protect that wire. I've sanded all the edges here. There's nothing really sharp, but just in case that wire, lays up against an edge, I want it protected inside of that. So that's all going to go into here, which is my little magic box, as depicted in previous videos. There we are. So I'm going to go ahead and probably set up the camera a little more stably so I'm not doing quite the shaky cam deal, and kind of show you what's going on inside this box, and we'll get all this wiring hooked up. Alrighty then. So it has been approximately 24 hours since my last video. It took a lot longer than expected, mostly just because wrangling this really heavy cable that's for the AC side of things, it's tough stuff to work with. I've dealt with it before when wiring up the little receptacles and stuff, but it's kind of another matter trying to get it into this little box and routing it through that cable that you see in the back, that little gray one, was challenging to say the least. It probably doesn't help that it's like the hottest days of the summer right now too, and I'm trying to work out in my garage and it's super warm. But anyway, as you can kind of see in the back of the frame right here, this is the cable that goes to the front main bus bars for the back positive and back negative, and you can see I have these little wires out here at the bottom, and those are the sense wires that I ended up actually re-crimping the whole thing to make sure that they were in there super securely, and you know, so it's those wires aren't coming out of there ever. And you'll actually have to cut off those studs inside the connector in order to get them out. So anyway, so that's super strong. Obviously all wrapped in orange electrical tape for safety orange. And then those go into the bottom of that conduit. You know, again, this one right here. So, you know, it's very very stiff stuff, difficult to work with, but I got everything in there. Anyway, as for the box itself, you can see that I've got, so these are the AC wires coming in. We've got our neutral, our hot, our other hot, so the hots in this case are red and black, and then we have this wire here, which is the ground. Now I've covered the ground in black electrical tape, so you can still just see a little bit of the actual bare wire for the ground, but mainly just so that as I'm stuffing stuff into the box, that this wire doesn't go and like touch something else. I mean, it shouldn't, but just in case, I figured I'd wrap it up in some black electrical tape to prevent accidental grounds, basically. Anyway, you can see that the green wire here is for the power for our little Dell power adapter, and so that's wired in. The white is on the same leg as the, you know, it's plugged right into the same wire as the white neutral coming in, and the green in this case is the ground, so that goes into the same one as the ground, and then the black is going to here, which is the same leg as the incoming, so it's one of the hots. It could have been either one, but I picked the black one just because, hey, black matches black and whatever. But so there we go. That is the wiring for this little green plug. So that should have 110 volts when this has 220. And then on the other sides, so other side of these contactors, we have a red coming out and going into, and I'm not sure how well the camera's making it out, but it goes into that side of the plug, and then the other one, the black one, goes onto this side for this hot leg. So both hot legs are switched with the contactors, and that's pretty much all there is to it. Those are still wired into the same relays they were before that I showed you in the earlier part of this video. And then up here, these are the pack positive and pack negative high voltage orange wires that are coming from that over there. So all that goes through the same conduit, through the same little stress relief gland nut here, and into the box. So we should have a pretty clean installation, and we're going to go ahead and plug it in now and see what happens. Alrighty then. So I have the main battery pack turned back on, and so we're at 198.9 volts according to the JLD 404. And as you can see, the battery charger is not plugged in at this moment because we don't really need that plugged in to do this test. We're just going to go ahead and see if the power supply in the box turns on okay, and if the little meter turns on without blowing anything up and catching on fire. So alright, so here we go. We're going to go ahead and now plug in to our charge port on the side of the car our magic generator power cord. And as I plug this in, we will go ahead and take a look at what happens with our little box. Hopefully it won't blow up. I can plug this in one-handed. Alright, here we go. We're in. the little meter came on. As you can see, we're at 198.9 volts. Also showing on the little display, that's good. And I heard the click, and as you can see in the left-hand side of the meter, that the top relay is on, the bottom relay is off. So that's looking pretty good. So what we're going to do now is test the disconnect, so that if that little red button is pressed, let's go ahead and do that now. So we're going to press the red button. I heard a pop from the back. Presumably that was the contactors disengaging and not something blowing up. And so now, according to our gauge, we're showing negative 0.8 volts. Not really sure why we're showing not exactly 0, but we're at, and both the relays on the left are both on, which is what we wanted it to do when we were at 0 volts. So even though the car is plugged in to the wall, it is not actually going to pass power to the charger plugged into this. So that's pretty cool. Alright, so I'm going to go ahead and get my little magic box all put back together here, and then we'll try it pretty much the same test with everything hooked up, or with the box put together, but without the charger plugged in quite yet, and then we'll try it with the charger. So I'll be right back. Okay, so as you can see, we have the Charger Buddy all set back up in the car, like it will be when the car is operational and driving down the road. All of the screws have been put back into the box. It's now all solid as a unit, and the only input into this is this one conduit that goes in that has both the sense wires as well as the AC input. The charger is unplugged from it at the moment, and that is something that is important. I wanted to point out that I discovered kind of a weird issue while I was working with this. So as you can see, we're at 0.0 volts, which means that our main pack disconnect is in fact disconnected up at the front of the car. And the two relays, the top one is in the on position and the bottom one is in the on as well. And so the bottom one is the one that shows on if it's below 50 volts. And since the big red button is off, we are below 50 volts. So therefore, the contactors are actually disengaged at this point because that bottom one is in the on position. So what we're going to do is plug in the charger, and I will show you what happens. So now this is kind of interesting. So the charger is off. It's in the on position here. The volt amp knob is all the way down to 0. But you'll notice that the voltage is now creeping up on our little meter. And I was very confused about this. I was like, what's going on with this voltage? Where's this coming from? The main pack is disconnected. All I can figure is that because the charger is plugged in to the main battery pack, positive and negative, just like this meter is, that we must be getting some kind of, I believe they call it leakage, like voltage leakage, from the ground and neutral that's coming from here through the charger and apparently to the battery pack. It's less than 1 volt, and I'm guessing there's not a whole lot of amperage going on there, if any, but it is kind of something that I found interesting. I thought that there might be some problem with my meter, so I took my multimeter up and measured at the bus bars in the front of the car, and lo and behold, they also show 0.08 up there. So it's definitely something funky with the charger. If I unplug this again, it'll go back to 0. So it's definitely getting that from the charger itself. And since we know that the two legs, the two hot legs on either side of this are disconnected by the contactors, it's only being connected with the ground and the neutral. So just something a little weird, little anomaly there, but not a huge deal. Since we're on the topic of the charger, I did want to mention something that was a little bit weird. So as you saw before how it's wired, I have let me unplug this so I can point to the actual thing here. Okay. So on this particular NEMA 14-50 outlet, so this is the ground, this is neutral, and both of these are hot. That seems to be the wiring standard that is used for such things. So what I ended up doing was, I'm trying to think upside down here. This one here that's closer to this stuff is the the red one, and this one is the black. Again, it doesn't really matter, but that's just how I chose it. So this one's the black, and this one's the red. Now, that's great. Works wonderful. When I hooked up the little NEMA 5-15 outlet in the box, so this is the thing that powers the Dell power adapter that makes this thing function, I spliced it in with the ground, with the black, and with the neutral. So those three are being used, the red is not used at all to make that function. So that works great. However, there is a little bit of an issue because the Manzanita wiring this is the wiring diagram for the Manzanita's adapter plug for making a adapter, which I've done here and have been using it for a while. So this is the 110 volt to 220 adapter plug that is made specifically to this diagram's specifications. What you'll notice here that's kind of bizarre is that the ground wire goes to ground, that's fine. The black goes to black, so that's our one hot leg. But then the white wire, which is supposed to be the neutral, is going to the other hot. Now, what this means, this is apparently fine for the charger. The charger, I guess, wants to see a hot and a neutral in that configuration to make it so that it knows that it's 110. But that doesn't work so well with my little box here, because with this one connected to the neutral and not this one, that means that my power adapter doesn't work in the box, and thus the gauge doesn't turn on and it will refuse to engage the contactors. So what that means is that I can't run my charger on 110 at this point. I'm really okay with that. It's one of those polite opportunity charging kind of situations where you'd have to make some modifications to the charger anyway. You'd have to go in and adjust the amp knob so you don't pop a circuit and all that kind of thing. So what I could do in that situation is I could still use my little adapter, plugging the charger in directly to it, and then plugging this into the wall, bypassing the charger buddy entirely. So not an ideal situation, but it's all I've got at this particular point. Maybe I can come up with some clever wiring, but I don't think so, to make it so that this particular wiring diagram would work with a 110 device plugged into this that'll operate both on 110 and 220 from this side going in. So anyway, that's just one little issue that I wanted to point out while I was going over stuff here. But let's go ahead and test this. So there we go. We're in nice and solid. So again, the charger is set to 0 amps. It is powered on. And we're getting our wonderful little voltage jump there for no apparent reason. But I'm going to go ahead and turn on the big red button in front of the car, and we'll see what happens. So as you can see, the bottom relay now has turned off, which completes the circuit to the contactors and allows everything to turn on here. So the top relay is on, bottom one is off, and what that gives us is it tells us that we're above the 50 volts, and so it's safe to power on the charger. So that works out pretty well. Just for sake of completeness, I'm going to go ahead and unplug the power on the side of the car, just so that we can observe what happens there. I think we already know what's going to happen, but we'll go through the motions anyway. So I'm going to unplug the main charge port on the side of the car. So quite obviously, we lose power to our charger buddy and also to the charger. And when I plug it back in, it immediately pops back on and is ready to go. So all that works as advertised and as we experimented before. So now the pack is actually pretty close to fully charged. We're hovering at 199.7 currently, and that's just a factor of that I had charged it before and then bled off a little bit to make this video. So it shouldn't take very long. Let's go ahead and crank up the charger to our maximum amperage, which is the 40 amps going into the pack. So it shows 36.8 on the display there. That apparently is the amount of amps coming from the wall, not the amount of amps going into the pack. So on my JLD 404, it's currently reading 34 to 36, and that's what it's putting into the pack. So this, again, shouldn't take very long. We can hear the annoying whistle in the background of the DC to DC converter, but that's about to be drowned out any second now by the charger, which makes quite a bit of noise itself as its cooling fans kick on. But anyways, this will hopefully not take too long. We're already at 206 and climbing. And mostly this is a factor of that red herring battery that I have up front, which hits full long before the rest of them do. So that one's spiking above 3.5 volts right now, and causing the whole pack to spike, which is fine. And it's going to cut off at 210. And there we go. So as you can see, the top relay has disengaged because we've hit that 210 cutoff as specified in the programming, and it will stay off until the pack settles to about 200 volts. Now this does take a while. I think one of the things that Jack had said was that these batteries take a good 24 hours before they're fully settled, you know, and representative of the actual voltage, you know, and kind of have bled off all that surface charge and so forth on the terminals. But what we can do is speed that along a little bit by engaging the motor and idling the motor for a bit to lower the voltage down to that 200 range as quickly as possible. So what I've been doing to test this is I'll turn on the radio, I'll turn on the fan blower, the heater. Of course it's really hot, so the heater's a bad idea right now, but you know, the heater. Headlights on, high beams, wipers going, power steering pump, you know, anything I can do on the 12 volt side of things. And then I'll also idle the motor about 3,000 RPMs or so, just with the transmission in neutral, so there's some resistance on the motor, but just based on the transmission resistance in neutral. So I'll go ahead and do that for a little bit and see if we can get this voltage down close to the 200 mark, and then we'll see what happens. Now normally we would have the charger would kick back on and start charging at that point, but since I'm going to be running my controller at the same time as I do this, I don't want to damage the charger. So what I'm going to do is kick the charger down to 0 amps again while I'm just doing this little bleed off master plan. So alright, so I'm going to go ahead and do that, and hopefully I can catch it on film when it trips. Okay, so it didn't really stay down there very long, below the 200, but it was enough that you saw that the charger came back on again and would resume charging. So once again, this would happen over a long period of time if the charger was left to its own devices, and the batteries were left to their own devices just to settle on their own. So anyway, that's kind of the whole process, just to kind of give you an idea of what this particular device does and you know, how it works. As you may be able to hear in the background, we've got some thunder rolling in again, so I'm going to go ahead and unplug the entire works here and call it a night. So anyway, if you have any questions, I will try to post a little schematic of this whole plan on my blog, and please feel free to comment. Take care and have a wonderful night.